All right, guys, so here we go. We're in Unit 9 now. We're talking about calculations. We're doing some calculations on the mole and grams and liters and number of particles. So that's what we're doing here today. These are the three main formulas that you're going to need to use. We have the grams of something is equal to the molar mass times the moles. We have 1 mole equaling 22.4 liters. This pertains to gases, and it doesn't matter how big the atoms or molecules are that you're talking about. No matter what it is, it's going to 1 mole of that substance is going to occupy 22.4 liters. And then we already know that 1 mole is 6.02 times 10 to the 23 things, whatever we're talking about. In this case, usually molecules and atoms, but if we had a mole of pencils, we'd have 6.02 times 10 to the 23 pencils. Just like 1 dozen equals 12 of something, 1 mole is 600 trillion things. So calculating a molar mass, we're simply adding up the masses of all the atoms in a molecule. So let's say we have carbon monoxide. We take the masses of carbon, since there's only one of them. The mass of carbon is 12. The mass of oxygen is 16. We simply add these numbers. So the molar mass of carbon monoxide is said to be 28, and the units for that is grams per mole. How about something slightly more challenging? Water. 2 hydrogen atoms. And the mass of hydrogen is 1, so 2 times 1 is 2. We only have 1 oxygen atom. Its mass is 16. And we're going to add these numbers up. So the molar mass of water is grams per mole. So look at these numbers here. This means that if you had 18 grams of water, which is not very much, a couple tablespoons, you would have 1 mole of water molecules, which means you would have 6.02 times 10 to the 23 water molecules in 1 mole. 18 grams would have this many water molecules. Here, because carbon monoxide is a slightly bigger molecule, you would have 28 grams, which would be a little bit heavier, but you would have the same number of particles. So the molar mass represents how many grams of that substance will contain this many molecules. Let's check out another one. How about CO2? Okay, we have 1 carbon. Carbon is 12. This time we have 2 O's. They're each 16. That's 32. Let's add them up. 44. So carbon dioxide has 44 grams per mole. So that means if you weighed out 44 grams of carbon dioxide, you would have that many molecules of carbon dioxide. How about something like table sugar? C6H12O6. The molar mass of this would be, I'm going to do it kind of in shorthand. We have 6 carbons. Their masses are 12. Plus there's 12 hydrogens. Each mass is 1. Plus there's 6 oxygens. Mass is 16. Do this math, it comes out to 180 grams per mole. So 180 grams of sugar would have this amount of molecules. So notice they all contain this amount of molecules, but the masses are different simply because of the size of each molecule. In this case, water is the smallest molecule. Only 18 grams would have that many. And then carbon monoxide, and finally the biggest molecule is the sugar molecule here, which would weigh 180. All would have 1 mole, which is this many molecules. All right, let's look at a couple other molecules. Let's look at something that contains some parentheses. Let's say calcium phosphate. All right, so what do we do here? We simply have to count up the number of atoms of everything. So calcium, there's 3 of them. Calcium has a molar mass of 40. Multiply those. How many phosphoruses are there here? Well, you take this little 2 and you multiply it by everything that's in the parentheses. So this means that there are 2 phosphoruses. Phosphorus has a molar mass of 31. Okay, and oxygen. How many oxygens do we have up here? 2 times 4. 2 times 4. There's 8 oxygens. Oxygen has a mass of 16. 16 times 8 is 128. And now we're going to add up these 3 numbers, and we're going to get 310 grams per mole. So if you weighed out 310 grams of calcium phosphate, that would be 1 mole, which means it would contain 6.02 times 10 to the 23 molecules of calcium phosphate. How about another one? Let's try this one, which we did in our lab. This is lauric acid. All right, so just be careful. You just have to count up how many atoms there are of everything. Let's look at this parentheses here. This 10 distributes to both the carbon and the hydrogen. So let's get a count of our carbons. 10 times 1 is 10. All right, but then here, don't forget this one. This is carbon number 11, carbon number 12. So there's 12 carbons here. Carbon has a molar mass of 12. 12 times 12 is 144. All right, how about hydrogens? Let's count up our hydrogens. So here, this 10 times the 2, that gets distributed. That means there's 20 hydrogens plus 3 and 4, 24. It has a molar mass of 1, so that's 24. And now let's do our oxygens. There's only these 2 here. Oxygen has a mass of 16. Oops. And we're going to add these up for the total. That comes up to 200 grams per mole. So if you weighed out 200 grams of this lauric acid, you would have 1 mole. This would be 310 grams per mole. Remember, both of these, because they're 1 mole, would each contain this many molecules. Even though the masses are different, the number of particles is the same. Okay, let's go on to some simple calculations, calculating moles and grams. This is going to be our main formula. Grams equals molar mass times moles. So we're going to use that to convert from moles to grams and back and forth. So the trick to doing these problems is always start with the number that you're given. There's only one number here, 10 moles. So we have to turn that into grams. We're going to use this formula. So we're simply plugging in numbers. We have 10 moles. We're trying to solve for grams, so this is our unknown. And molar mass. Can we calculate a molar mass of water? Of course we can. We already said it was 18. We have 2 hydrogens plus an oxygen. We're going to plug that in here. We get 180 grams. Okay, so 10 moles of water would weigh 180 grams. Very simple. Just plugging in numbers to our formula. How about going the other way? Let's say we have 5 grams of something, some table salt. How many moles would that be? Okay, again, start with a number, 5 grams. Here's 5 grams over here. Put that in there. We're solving for moles, so we don't know what that is yet. What's the molar mass of sodium chloride? Sodium has a mass of 23. Chlorine has a mass of 35. Since there's only one of each, we're going to just add those up. 58. Okay, so now a little bit of algebra. Remember, you're going to want to divide by the number that's next to your unknown. So in this case, it's the 58. Because look what happens. This cancels with that, so now you just have moles equals 5 divided by 58, 0.086. Whoops. Moles. There we go. Simple conversions just using a formula. Let's go to our moles and volume calculations. We're going to use this relationship. 1 mole equals 22.4 liters. So what that means is say you have a box that's 22.4 liters in volume. So it's like a box that's like 12 by 12 by 12 inches. This is 22.4 liter box. So if you fill this up with gas, let's say nitrogen gas, and 2 diatomic nitrogen, this would be 1 mole of nitrogen. It could be helium. It doesn't matter. It doesn't matter what the gas is. It would be 1 mole at something called STP, standard temperature and pressure, which is like room pressure and temperature. This will change when we start doing gas laws, but for now, we're just going to do it like at room temperature conditions. Okay, no matter what gas it is, under these conditions, they're going to take up a volume of 22.4 liters. It doesn't matter on what size the gases are. It could be krypton. Krypton's a big gas molecule, gas atom. It would still be 1 mole. It doesn't matter because the gas molecules are so far apart, their size doesn't matter. So no matter what gas we're talking about, 1 mole occupies 22.4 liters. So let's do a conversion. Here we go. Let's start with a number, 10 liters. I don't see any numbers there other than that, so let's start there. We have 10 liters. Let's convert it to moles. We're going to use this relationship. So doing these conversion problems, the trick is canceling out your units. I want to put this over 1 because I want a numerator and a denominator because my conversion is going to have a numerator and a denominator. It doesn't change that 10 divided by 1 is still 10, so I didn't change the value here. I'm just trying to make it a little bit easier to think about. So 10 liters here. So the trick is I want liters down here. Where is there a number by liters? Here we go. 22.4 liters is 1 mole. Here is our relationship. This has to be some true conversion. So look what happens. Liters here cancels with liters here. And now we multiply across. 10 times 1 is 10. 1 times 22.4 is 22.4. And 10 divided by 22.4 is 0.45 moles. Because look, this is our unit here. It didn't cancel out anywhere, so that's going to be what our unit is. This is our answer. So 10 liters of helium, or any gas really, would be about half a mole. How about this one? Let's start with moles and go to liters. So again, we're going to start with a number, 7 moles. I want to put it over 1, just because I want a numerator and denominator. So, but this time we're going to put moles on the bottom. 1 mole is 22.4 liters. Notice the difference. Here moles was on top, liters was on bottom. Here liters is on top, moles on bottom. And it's because it depends on what you start with. Moles there, cancels. So this time we're multiplying 7 times 22.4 divided by 1 times 1. This comes out to about 157 liters because our unit is in liters here. That's our final answer. So these are just one-step problems using our conversion, and the trick is just getting your units straight so you know whether you're multiplying or dividing your initial number. Let's do the same thing, but this time with number of particles. So remember that 1 mole equals 6.02 times 10 to the 23 particles. Atoms, molecules, whatever we are talking about. Doesn't matter. Okay, so let's do the same thing we just did. Let's start with a number, 7 moles. I'm going to put it over 1. Now, moles here. What's going to go down here? Moles. 1 mole. Up here is the number of atoms because we're dealing with atoms. So 6.02 times 10 to the 23 atoms. Look what happens. Moles cancels. Our units in atoms, we're going to multiply 7 times 6.02 times 10 to the 23. And we're going to get 4.2 times 10 to the 24 atoms. That's how many 7 moles of xenon would contain. 4.2 times 10 to the 24. All right, let's go the other way. Let's say this time we start off with molecules of some water. So again, we're going to start with a number. That's 3 million, so it's 3 times 10 to the 6 molecules. Get into a habit of writing your units down because it's really going to prevent you from making careless errors. So we know if molecules is here, we need the word molecules down here. There's our relationship. We have this many molecules is 1 mole. So now we're going to divide 3 times 10 to the 6 divided by 6.02 times 10 to the 23. Molecules cancels. Our units are going to be in moles. That's good because that's what the question asked. And this comes out to 5 times 10 to the negative 18 moles. So make sure you're getting this on your calculator because a lot of people make mistakes dividing exponents like this. Sometimes you have to put in parentheses when you're on your calculator, so make sure you get 5 times 10 to the minus 18 for this problem. All right, so let's go on to the final part of this where we're doing multi-step calculations. This time we're going to jump between moles and grams and liters, and the common factor here is you have to get to moles first. Get to moles first. So important. You're going to have to remember that for the rest of your life. So here we go. We're going to use a combination of our 3 different formulas to do these problems. So let's get to it here. Where's there a number? Here's one, 10,000 liters. We're converting it to grams. So there is no one formula that goes from liters right to grams, so we have to get to moles first. So let's take the 10,000 liters, step 1, and convert it to moles. How did we do that? Well, we just did a couple examples a minute ago. Liters on top, liters on bottom. 22.4 liters is 1 mole. So 10,000 divided by 22.4 moles. Okay, we're not done though. It says grams. If it said how many moles, if our question was asking us about moles, we'd be finished. This would be our answer. But it's asking us for grams. So we have to take it to step 2. We have 446 moles. How do we get it to grams? Well, we go back to this formula. Here's our moles, 446. We're trying to solve for grams, so we're just plugging the numbers into here. The molar mass of helium, we're talking about helium. Molar mass is 4. So we're simply multiplying those numbers, and we get 1,758 grams. So there you go. That's how we went from liters to grams. 2-step problem by getting to moles first. So 1,758 grams of helium would occupy 10,000 liters. Imagine like a balloon, big balloon. That's how many grams of helium would be in it. All right, let's try another one. Let's go the other way. This time we're starting off with 50 grams, and we're converting it to liters. So this is going to be a 2-step problem. Unless one of these words says moles, it's going to be a 2-step problem. If one of them said moles, then you would just do a 1-step. So step 1, is converting grams to moles. Get to moles first. I can't tell you this enough. You got to get to moles first. So how do we get from grams to moles? This formula. Plug in 50 grams. The molar mass of N2 is 14 times 2 is 28. And we're solving for moles. Think of it as X, right? That's our unknown. We're solving for moles, is X in this case. Divide by 28. Always divide by the side that your X is on, because this cancels out. We get X equals 1.8. All right, so that's 1.8 moles. 1.8 moles. Do we want moles? We do for a second, but we want liters eventually. So step 2, we have 1.8 moles. So how do we get it to liters? We use this relationship. Moles on top, moles on bottom. 1 mole is 22.4 liters. Moles cancels. 1.8 times 22.4. It comes out to about 40 liters. All right, so 50 grams of nitrogen gas would occupy about 40 liters. Let's try another one, another couple. All right, this time we're going from number of water molecules. We have 1,000 water molecules and we want to convert them to grams. So 1,000, that's not very many, and we know molecules are really small. So it's probably going to be a small number. So step 1, write the number that you're starting with, 1,000 molecules. Get to moles first. Get to moles first. I'm going to write it again because it's important. How do we get to moles? Well, molecules on top. This is molecules on the bottom. Is 1 mole. Okay, molecules cancels. So we're going to take 1,000 and divide it by 6.02 times 10 to the 23, which comes out to 1.7 times 10 to the minus 21 moles. Okay, check your math. Make sure you're getting that same number. There should be a negative exponent here. All right, so we're trying to get to grams though. Oh, so we're not done yet. We have to go to step 2. How do we convert moles to grams? Well, it's this formula. Okay, here's our moles. 1.7 times 10 to the minus 21. We're solving for grams, so we don't know that yet. But we do know the molar mass of water. It's 18 grams. That is a really, really small number. But we're only talking about 1,000 molecules, so it's going to be a small number. That's your final answer. All right, let's try another one. We have a glass of water that has 300 grams. It's about a standard glass of water. How many molecules would this be? Okay, it's kind of interesting. 300 grams. Start there. What's the first thing we want to do? Get to moles first. All right, so grams, here's our grams and mole formula. Plug in what you know. 300 grams. The molar mass of water is 18. Solve for moles. Okay, divide by the number that's closest to your X. This comes out to 16.7. That's how many moles you have. Okay, that was step 1. Getting to moles, we got to moles. Step 2, what are we trying to find out? How many molecules is this? Oh, good. All right, so we have 16.7 moles. We know how to convert that to molecules. Moles up top, 1 mole on the bottom is Avogadro's number. Molecules, And this is going to come out to 1 times 10 to the 25 molecules. That's a lot of molecules of water. So there you go. 2-step problems. Now you can do it all.